The topic of discussion that we are going to have right now is we are going to talk about descending tracts. Before this, we talked about what? We talked about somatosensory pathway or ascending tract, but now it is the time for descending tract. Now in this video, we'll be talking about all these diagrams. We'll be having all the things in detail also. So without delay, let's begin our discussion. So descending motor pathway, right? Descending or motor pathway. It is called motor pathway because these are efferent, right? What are these? These are efferent. These are efferent, that means these are what? These are output pathway. Okay, let me, these are what? These are efferent. These are efferent, right? These are what? These are output pathway. Now why these are called output pathway? Let's correlate with our sensory. Sensory, what was our sensory? Sensory was our, right? Sensory was our efferent pathway, right? Efferent, or we can say what? Input pathway, or what? Ascending pathway. Okay, similarly descending tract is our efferent output pathway. Okay, now here what is going on is that in ascending pathway, what we did, we just what the input, the impulses, the information, sensory information, what we did, we send it all the way to what? Cortex, right? We send it all the way to cortex. Now what is going on here is, now we are what? We are sending what? Motor response from this cortex area to our what? To effector area. Now so it is called what? Descending tract. It is the efferent or output pathway. We are providing the output right now. Okay, so we should start from higher center. Now what is that higher center? The higher center is our what? Our cortex, right? What is our higher center? It is our cortex. Now from cortex, right, from cortex region we are sending all the way to what? To our effector region. Effector region. So for example, okay, this is our path. What is this? This is our motor cortex. Now from this motor cortex we are sending all the way, passing through what? Our this brain stem, all the way to spinal cord, and then to what? To our muscles of limb, muscles of what? Midline, these areas. So this is what? This is our descending or output or our what? Motor pathway. Okay, now okay, let's talk something about, okay, now let's begin our discussion from what? From our what? Cortical motor areas. Now what we are saying is, we are saying cortical motor areas. Now why we are saying cortical motor areas? Why are we saying cortical motor areas? We are saying it because motor areas are found in cortex, right? Motor areas are found in cortex. Now okay, now if you remember, what is this? This is our, let's suppose this is our central sulcus. What is this? Central sulcus. Now before this central sulcus, what we have? Before this central sulcus we have what? We have precentral or frontal cortex. What I'm saying? Precentral or frontal cortex. Frontal cortex. This was what? This was our motor cortex. Motor cortex. Okay, that means motor function are all regulated right here in this region. Now behind our this central sulcus, what we had? After this we have post central. We have what? We have post central sulcus. Now these post central sulcus, right, these are called what? Parental cortex. What these are called? These are called our what? Parental cortex. Cortex. Now these were what? These were our sensory cortex. Sensory cortex. Now that means the sensation, the sensory cortex, the sensory, that means our what? The sensory functions were regulated from what? From this area. Similarly, the motor function are regulated from this area. From what? Precentral or frontal cortex. So the motor cortex is at what region? It is at what? Our what? Frontal area. Now these motor cortex, it correspond to what? It correspond to our Brodmann number. How much? It corresponds to our Brodmann number. How much? The Brodmann number that it is what? It is corresponding to is our area number what? 4 and 6. Okay, now there are several what? There are several let's say there are several what? Now these our motor cortex is also divided into what? Several region. Now what are the several region of this motor cortex? The several region are initially the first one is our primary motor cortex. What I'm saying, primary motor cortex. Okay, this primary motor cortex is located at Brodmann's number 4. Now what it is doing, this primary motor cortex, it is controlling the final execution of motor movement. What it is doing, controlling the final execution of motor movement. Similarly, there is what, there is, okay, it is controlling the final execution of motor movement. What about the generation of idea? That means generation of idea, it is done by cortical association area. It is not done by primary motor cortex, it is done by cortical association area, and after being what, generated by the idea being generated by cortical association area, it will be what, finally executed by our primary motor cortex. Similarly, there is what, there is pre-motor cortex also, that is pre-motor cortex. Now it is responsible for, it is located in Brodmann's number 6. Now it is responsible for what, it is responsible for setting posture before movement. That means we need to what, we need to sit steadily, or we need to sit in a specific position before writing or before working on our laptops, like that, right? Now it is done by premotor cortex, that is located in Brodmann number 6. Now another is there, the final one, that is our supplementary motor cortex. What it is supplementary motor cortex. Now it is also located in Brodmann number 6, and it is responsible for bimanual coordination. Now what is this bimanual coordination? Okay, it is the bimanual coordination, that means it is controlling what, our left and right part of our body. It is controlling left and right part of our body. So this was what, this was about some of the information about our what, the cortical motor area. So now this after this cortical after this brief introduction about this cortical motor areas, the thing that I would like to add up right here is there are two, this descending tract consists of two types of tracks. The first one is our what, the pyramidal track. Now why we are saying this pyramidal track? Okay, now before getting into that discussion, what we will do right now is we will see location of descending tracks, right? What we'll do, we'll see the location of these descending tracks where, in our spinal cord. On our spinal cord, as you can see right here, there are several positions of them, right? And then we'll discuss briefly about these tracks individually. Okay, now this descending track, it is divided into two types. What are the two types? These are pyramidal and extra pyramidal. Talking about pyramidal and extra pyramidal, the pyramidal have what, the pyramidal, why these are called pyramidal? These are called pyramidal because pyramid are being formed in medulla oblongata, right? Medulla oblongata, that we'll see in brainstem, that's why. And these have what, these are mainly from cortex, right? These are mainly from cortex, these originate from cortex, and then these go to spinal cord. These get originated from cortex and then they go to spinal cord. So the pyramidal tract are also called our what, corticospinal tract. What I'm saying, the corticospinal tract, because they are being originated at cortex, right? And then they are what, they are moving toward spinal cord. And another is our extra pyramidal. Now extra pyramidal, why extra pyramidal name? Extra pyramidal because why extra pyramidal, that means they are not originating from cortical region, they are originating from what, other subcortical region, that's why. Okay, now moving further. Okay, now briefly, the thing that I would like to add up right here is, one is our what, one is our pyramidal, and another is our what, another is our extra pyramidal. Now these pyramidal and extra pyramidal, these pyramidal are also called what, corticospinal tract. What I'm saying, corticospinal tract. Don't worry, we'll see this thing in diagram, spinal tract. And there are several other extra pyramidal systems, right? There are several other extra pyramidal system that we need to maintain, that we need to mention, like tectospinal, rubrospinal, rubrospinal, reticulospinal, we have vestibulospinal, right, and other many. Okay, now here in this diagram, now let's now let's not mug up everything. Now let's go toward corticospinal tract, the pyramidal tract. Now these corticospinal tract or pyramidal tract, these are also further divided into anterior corticospinal tract, anterior corticospinal tract, and another is our lateral corticospinal tract, lateral corticospinal tract. Now okay, let's see these things right here. Okay, yes, as I said that what is this is our spinal cord, right? This is our spinal cord. We said that we will be looking the location of different tracts in spinal cord. Okay, now this is the gray matter of spinal cord. Now here, okay, now as I mentioned that pyramidal tract, it consists of two type of tract, right? One is anterior corticospinal tract and one is lateral corticospinal tract. Now these lateral, as name suggests, it is present on lateral location, and this anterior, it is what? It is located anteriorly, okay, or we can say ventral corticospinal tract and what? Lateral corticospinal tract. Okay, now these tracts, right, these tracts, this anterior corticospinal tract, we'll see this thing right here in this diagram, so no need to worry. Now let's take it as a fact. This anterior corticospinal tract, these are uncrossed, that means they will go on the same side of origination. But this lateral corticospinal tract, they cross the midline. Okay, here that I'm showing, this is our what? This is our lateral corticospinal tract. As you can see, it is crossing the midline. Okay, this is the midline of our body, right? The anterior corticospinal tract, it is going all the way down without dissociating, but this lateral corticospinal tract, it is crossing the midline, right? It is crossing the midline right here, and this is our lateral corticospinal tract. That means our corticospinal tract, it is what? It is anterior and it is lateral corticospinal tract. That means here as a whole it was what? It was only corticospinal tract, but now after dissociating, it is lateral and it is anterior spinal cortical tract. Out of 100% of corticospinal tract, 85% of the corticospinal tract, it is lateral corticospinal tract, or we can say that 85% of the corticospinal tract, they dissociate into another side, but this 15% they do not dissociate, that means they move along the same side. Okay, this is one thing about what? Our this anterior corticospinal tract and lateral corticospinal tract. Now what are these what are the function, right? They what they do is they carry what? Motor impulses of skilled voluntary movement. What I'm saying, they carry the motor impulses of skilled voluntary movement. Okay, now let's move into what? Let's move into our what? Our extrapyramidal system. Now talking about extrapyramidal system, what we have is we have various tracts, right? For example, we have rubrospinal tract, we have vestibulospinal tract, we have tectospinal tract. Okay, now what is important about this rubrospinal tract is that rubro, name suggests, rubro means red. It is called rubrospinal tract because red nucleus is present in midbrain, right? Red nucleus is present in our midbrain. Now what is its function? It, okay, let's not go into function. Another is our vestibulospinal tract. Now this vestibulospinal tract, now, right, vestibulospinal tract, it is present between our this rubrospinal tract and our tectospinal tract. Rubrospinal tract and our tectospinal tract. Yes, we're talking about what? We're talking about vestibulospinal tract. Okay, now let's do what? Let's do one thing, that is rubrospinal tract, vestibulospinal tract and tectospinal tract. Let's talk about function of this rubro, vestibulo and tectospinal tract. Now what is this rubrospinal tract doing? It is facilitating flexor. It is facilitating what? It is facilitating flexor and inhibit extensor. Now to do this opposite action, it is done by what? It is done by vestibulospinal tract, that is it facilitates extensor and inhibit flexor, right? It facilitates extensor and inhibit flexor. This rubro and what? Vestibulospinal tract, these are opposite in function. Okay, now what about this tectospinal tract? Tecto, the name suggests. Now this tecto, it is the name, it comes from the name tectum, that is the part of midbrain. Now what it is doing, it is coordinating the movement of head and neck with eyeball, right, based on visual stimulus. Okay, for example, if we are watching moving vein in road and we are just locking our eyes into that vehicle, now what we'll do is we'll just move our eyes, move our head neck to as that vehicle moves, right? And that is done by what? Tectospinal tract. Okay, now there is one special connection between this tectospinal tract and what? Our this rubrospinal tract. Now what is the special connection between this tectospinal tract and rubrospinal tract? That they start at same level on midbrain, right? Rubrospinal tract and tectospinal tract, they start at same level in midbrain. right? Now midbrain, and another thing is that what is the important thing, what is another connection is that they dissociate at same level, right? They dissociate at same level and descend down to reach spinal cord. Okay, that means rectospinal tract and rubrospinal tract, they originate at same level in the midbrain, and they dissociate at same level and descend down to reach spinal cord. That is one main thing. Okay, now to know that thing in detail, what we need to do is we need to have what is this is our midbrain, right? This is our midbrain, the TS of midbrain at the level of what, superior colliculus. As you can see, superior colliculus is right here, right? Red nucleus is right here. Okay, now as we are saying, but we are saying, okay, now this is our tectum, right? Tectum, tegmentum, and cerebellar peduncle. Now this tectum is the dorsal most one, tegmentum is the middle one, and cerebellar peduncle, why the ventral most part. Now why we are calling here the cerebral peduncle? We call it because descending tract of cerebellum are also present right here. Descending part of cerebellum are also present right here. That's why we are calling it what, the cerebellar peduncle. Okay, here we were talking about what, okay, we're talking about tectum, tegmentum, and cerebral peduncle. Okay, now here we are talking about the dissociation of tectospinal tract and rubrospinal tract. As you can see, this is what, this is our tectum, so tectospinal tract is right here. Now here the tectospinal tract dissociation is taking place at what, at this tegmentum region only. As you can see, at the region of tegmentum, but where, at dorsal tegmentum, right? At dorsal tegmentum, here at the back of this tegmentum, dorsal tegmentum. But here as you can see, the rubrospinal tract, its dissociation is taking place at the level of what, at the level of our tegmentum only, but in ventral, that means a bit further of our this tegmentum. That means both dissociation is our tegmental dissociation, but the dorsal dissociation is our tectospinal tract and ventral dissociation is our rubrospinal tract. So that's the difference. Okay, now moving further, what is this? This is our pyramidal tract. It is the pyramidal tract, as I have already said, corticospinal tract, right? Corticospinal tract. Okay, now here what we need to do here, right here is, in this diagram, as you can see, the highest center is our motor cortex, right? The highest center is our motor cortex. Now from this motor cortex, the starting point from here, what will happen, the motor response will go all the way to brain stem. These are the brain stem, midbrain, pons, medulla oblongata. Now the 15% will go without dissociating, right? As you can see, 50% they are anterior corticospinal tract, and the 85% will dissociate where, at the lower medulla oblongata, right? These the 85% will dissociate at the level of lower medulla oblongata. This is called pyramidal dissociation, and this the percentage, it accounts for 85%. Now what will happen after what, let's okay, now after it reach into spinal cord, what it will do is, it will rely onto what, it will rely onto our what, lower motor neuron. Now this lower motor neuron, these are also what, these are also having different nucleus. Okay, now here the nucleus that on which our this anterior corticospinal tract is relying is our what, the medial nucleus, right? The medial nucleus, it is our medial nucleus. Now here this medial nucleus, right? this medial nucleus of this lower motor neuron, right? It is the point of what, relaying of our this anterior corticospinal tract. Now this medial nucleus of lower motor neuron, it is responsible for what, motor action of our midline muscles, that means the axial muscles. Now what about this, our lateral corticospinal tract? The lateral corticospinal tract, it will also it will also come into spinal cord, and then it will rely on what, the lower motor neuron. But here the lower motor neuron is of what, lateral nucleus of ventral horn, and this lateral nucleus of ventral horn, right, will, what it will do is, it will be responsible for motor action or motor activities of limb muscles. That means lateral muscles of ventral horn will supply the limb muscles and will be responsible for the motor function of these things. Okay, here one important thing that we can correlate here is the limb muscles, right? These are coordinated, let's say these are coordinated by lateral nucleus, right? Lateral nucleus, and the tract is our lateral corticospinal tract. So this was what this was about, in brief discussion about our pyramidal tract. Okay, now Yes, we had a brief idea about each and everything right here. Now I would like to add up something. Okay. Yes, we discussed about corticospinal tract, the anterior corticospinal tract, the lateral corticospinal tract, right? Lateral corticospinal tract. Similarly, we talked about extrapyramidal tract. We talked about rubrospinal tract. We talked about vestibulospinal tract. We talked about tectospinal tract, right? Now along with it, we have reticulospinal tract also. And they have their specific functions that we have already mentioned. So this was all about a brief introduction about descending tract. I hope you got the topic. Thank you and have a great time.